Hi everyone, my name is Cameron McKenna, ND2. I'm from Detroit, Michigan, and I'm stationed here at Little Creek, Virginia to talk about Navy diving and the Mark 16 underwater breathing apparatus. This is a special rig in that it's low magnetic, so it doesn't set off bombs. It doesn't let gas into the water when we're diving, so it's safe, and it gives us face protection from whatever problems you might encounter out in the water. Contrary to scuba, we actually have a much greater depth capability. It goes to 300 feet of seawater with mixed gas, and that gives us a greater bottom time, so decompression is significantly less. It has a recirculating system here that filters out our carbon dioxide. Well, there's 4 internal components to the Mark 16. That has the housing system. This protects all the valuable pieces inside. There's electronics. This is a computer-controlled system that mixes gas. The diver needs to breathe a higher percentage of oxygen. That enables us to limit the amount of inert gas that we take into our body, and that alleviates decompression sickness. Gives us a tremendous advantage. Rather than scuba, we have extended bottom time, like I was saying, and we have a greater depth capability. So when we're working underwater, we have outstanding abilities and unique features. Now we have a recirculation system, so the gas we breathe goes back inside this filter, and we remove carbon dioxide so we don't pass out when we're diving. It's very important. And there's pneumatics that control the amount that we take in and the amount that we release. So these 2 bottles just by themselves right here are capable of allowing a diver to survive several hours in the water. That's just because the recirculation and pneumatic system working together filter out toxic or excessive inert gas. So this is our common scuba setup. It's a self-contained underwater breathing apparatus. It's lightweight, and civilian scuba divers are very familiar with this. It's got 80 to 100 cubic feet of compressed air in the tank, and this buoyancy compensator allows you to float up and down in the water column. You have a regular second stage regulator, and this will give you a typical capability of usually less than an hour at 100 feet of seawater, and that's, as you can tell, it's a pretty significant difference from a Mark 16 rebreather. So we have 200 more feet and several hours of breathing on this rig. It's just that this is lightweight. The tank is about 32 pounds, BC's maybe 5, and the regulators just a few. This right here is about altogether maybe 93 pounds when you put it together. So this is a little bit easier to use. We use it in shallow water search, and this is a special warfare rig, so it has unique capabilities, but it's just a little bit easier to get this one in and out of the truck when we're working. So I'd like to show you one of the most important pieces of Navy diving gear we have. This is called a SNDL, or Standard Navy Double Lock Recompression Chamber. And we have an ASRA here. That's an air supplied rack assembly. And it's basically just bottles of air that we use to fill the SNDL. So we take a afflicted diver, say, in our dangerous job, somebody got hurt. We can press them down back to depth only in the air, and we use that pressure to alleviate neurological damage, things like memory loss or pain in the chest, confusion, anything like that. We send them down to depth and alleviate the pressure in their body and give them a treatment. 165 is our max depth for treatment. We can use this for anything like a diving related injury, candidate pressure test if we want to see if you're tough enough to make it as a Navy diver or EOD tech. We can also do surface decompression in diving, so we send a diver down at depth for a very long time and we don't want to have them do in-water decompression. We use the chamber to do their decompression status and remove inert gas from their body on the surface after we bring them up, so we save time and we don't expose them to hypothermia and the elements. if something were to ever happen in an emergency, we can set this up in about 15 minutes. So we're very lucky to have just about 6 of them on here at site, just in Little Creek, Virginia. So, as a second class, my typical job would either be logs keeper or driver of the chamber. Now I use these valves to control the pressure and depth that we send the afflicted diver to, or the candidate. And you have a viewport here, so I can keep an eye with the supervisor and the logs keeper. We take a look at the patient or the diver, and we can tell their status through a neurological exam. And we send a tender, so that's another unafflicted diver, in the chamber with them, and they monitor those things and they share information with us. We also have a medical recompression lock here, so we can give them food if there was a really bad situation that took several days. You can feed them or we'll take care of them through the lock. And I can also show you how to get inside now. So guys, this is the entrance to our SNDL chamber. If you have an afflicted diver or candidates or anybody else just doing testing, they get in here. It's a cramped space. It's really not for everybody. Navy diving's a arduous, dangerous thing. So let me show you what it's like to get inside. Well, welcome inside, guys. Like I said, it's not for everybody, and it's not exactly a posh living environment, but this is what we do as divers. So right here, we've got our patient, ND2 Houston. He was looking for a bomb in 300 feet of seawater, and unfortunately he did get hurt, so we pressed him down to depth, and he seems to be doing better now. Under other circumstances, though, we could have a candidate come in here, maybe somebody like you, and we'd send you down to 60 feet and just see if you can tolerate the basic pressure. A typical salvage mission, you might prefer to do surface decompression. Like I was saying before, that you have less decompression in the water, so a diver isn't exposed to hypothermic or who knows, maybe even a tiger shark. You could load a few divers in here, and they need to remove the inert gas from their body in a dry, safe environment. Now, this allows us to take a diver out of the water, and we do that safely here. You could do this on a ship, or you could do this on a pier, somewhere more controlled, basically. And you see, it might take even hours or days in a more unusual situation, but our Navy divers, and that's what we excel at. And guys, thanks for stopping by. I hope you learned something about Navy diving, and I hope you enjoyed it. Sorry we missed you this year at Fleet Week. Hope to see you next year, and we'll have a dive tank at Times Square. Take care.